Hello everyone, welcome back to JP Science. Today we're going to be talking about the difference between distance and displacement. Okay, this is a very important distinction, and a lot of students actually don't really pay attention to this until it comes back to bite them later. So hopefully this is a helpful video for you, okay? And so I'm going to start off by just explaining the concepts, and then I'll have a couple of interesting examples that are going to help you really understand and solidify this in your brain. Okay, so first things first, let's define displacement. Well, displacement is the total length of the path that an object travels, okay? And we should note that distance is a scalar, okay? Meaning it only has magnitude and no direction, right? And so thinking back to this definition of total length of the path an object travels, we can actually maybe say this in another way, and that would be how much ground is covered, right? So we're really worried about here the length of the path. So how much ground do we cover during the actual movement along the path that this object travels, okay? Now for displacement, we're talking about a vector here, okay? So there's now magnitude and direction. So direction is an important component, right? And the definition of displacement is a change in position from the initial to the final position. And so we're no longer worried about the actual path traveled. We're only worried about what is the final position relative to the initial position, okay? And we can describe that through this formula here, okay? All right, so here's our first example. Let's say that there's a track that is 400 meters. So if you went around this track one time, you would have traveled 400 meters. Well, if this person started at this point, ran around the track, okay, and came back to the exact starting point, all right, what would be the distance that this person traveled? Well, it would be 400 meters, okay? And the reason for that is the path that this person traveled has a length of 400 meters, okay? However, would that be the case for displacement? Well, remember, displacement is the change in position. So final minus initial position, right? Is there any difference in the final and the initial position that this person traveled during this time period? No, right? Because they come back to that exact same spot. So the displacement is actually 0 meters. Let's move on to the next example here. And this example says that a person walks 3 meters to the right, turns around and walks 8 meters to the left, and then turns around again and walks 2 meters to the right. Okay, well, let's think about what the displacement is going to be. So let's just say that this person starts at point 0. Okay, so that's the initial position. Okay, and this person walks 3 meters to the right. Okay, so in terms of the distance, so far this person has covered 3 meters of ground. Okay, now the person turns around and walks 8 meters to the left. Okay, so now this person's going to end up at -5 meters relative to our point 0. Okay, but still, the length of that distance traveled is 8 meters. Okay, and then finally, the person walks 2 meters to the right. Okay, and so that's another 2 meters of ground covered. So the distance is going to be 13 meters. Okay, well, how about the displacement? Okay, remember, displacement is final position minus initial position. Okay, and based on what we drew here while we kind of observed or thought about the actual path that this person travels, we can see that the initial position was here at 0, and then after moving to the right and then to the left and then back to the right again, this person ends up at -3 for the final position. Okay, so the final position is -3 meters minus the initial position, which is 0 meters, and so the displacement is -3 meters. And so as you can see, right, distance, we have to consider the path that the person travels, okay, while displacement is just comparing where that person ends up relative to their starting point, okay? Here's another example, okay? 0 represents our sea level, okay? And the situation here is going to be that an object falls from 38 meters above sea level down to 10 meters below sea level, which would be -10 meters, right? So let's think about the distance, right? Well, to get to sea level from 38 meters, a distance of 38 meters has to be covered, right? And then to get to 10 meters below sea level, another 10 meters. So the distance is 38 meters plus 10 meters. It's going to be 48 meters, okay? How about displacement? Well, what is the final position, right? It's negative 10 meters, right? So 10 meters below sea level. And what's the initial position? It's positive 38. So negative 10 minus positive 38 is going to give you a displacement of negative 48 meters. Okay. All right, this is our last example here. And in this case, what I've drawn out is kind of the path that a bouncy ball might take as it falls from its max height down to the ground and then bounces a couple times. Of course, this is not exactly what a ball's path is going to look like as it bounces. It'll probably bounce a couple more times, and will it have these specific measurements? Probably not, but just for the sake of the example, I've drawn this out, okay? So let's think about what the displacement would be. So that's the first thing we're going to do, okay? So I guess since the ball, we're thinking about the vertical path of the ball, like as it bounces up and down, let's write this out as the change in y, okay? So y final minus y initial, okay? And so the final position is going to be 0 meters, right, when it's on the ground after it's done bouncing, okay? So 0 meters minus the initial position, which is 10 meters above the ground, okay? And so the displacement is negative 10 meters, okay? Well, how about the distance? Well, as the ball bounces up and down, it covers a significant distance because it travels as it goes down to the ground and then travels as it goes back up and then back down and back up and back down, and however many times that repeats. So here, if you think about it, right, starting from the 10 meters, it falls 10 meters. So it covers 10 meters of ground, okay, and then bounces back up to 7 meters, falls down another 7 meters to get back to the ground, back up 6 meters, down 6, up 4, down 4, up 3, down 3, okay? And so that would be here written out like this, right? And so the distance would be all these values added up together, and you would get 50 meters in that case, okay? And so here, again, you can see that there is a significant difference between displacement and distance. So it's really important to know the difference.